All right, now we'll get back to the question in just a moment, but now we'd like to welcome the Rochester Museum Science Center and Mr. Tim Cawley to the show. Hi, Tim.
Hi, Tim.
Hey guys, good to see
have
you
you
again.
back.
Welcome back.
Happy to be here. Today, we're going to do a couple of things. We're going to work with light and color.
All right, great.
Now, we have those together because without light, you can't have color, and without color, you can't have light.
Okay,
When you
yeah.
think of natural light, what do you think of the biggest natural light?
I can answer that one.
Go ahead.
I'll leave the tougher ones to you, but I would naturally think of the sun.
The sun, exactly. Now, when you think of the sun and you think of color, what's one of the really cool phenomenons that happen with the sunlight? And it would happen on a day like today, because what was it doing outside today?
Yeah, it was raining.
Yeah,
Raining.
so
what
rainbows.
does
Yeah.
rainbows, exactly. And that's because the rainbow, the sunlight goes through the raindrops, and when it does, the raindrops refract the light.
Yeah, what does that mean?
Refract
we talked
means-
about that earlier. What does refraction
It
mean?
means that it bends the light. It actually starts to basically scatter it, bends it, and spreads it out. Because sunlight, even though you look at it up in the sky, it looks yellow. That's because of how it comes through our atmosphere. It's actually white light, and it has all the colors in the rainbow.
And I like the way that you mentioned that it bends, that if the Earth didn't get in the way, it would actually be a
that's right.
circle.
That's
You
right.
know, I
It's-
always thought it was
right.
just a semicircle no matter what.
It's
but
like this summer was really hot. You were probably playing with a hose sometime, and you have it where it's spraying out in the sunlight.
Oh, yeah.
And the rainbow is
Oh, yeah,
a complete
okay.
circle. So it would be if the Earth didn't get in the way.
Yeah.
But the cool
That's
part
great.
about that is there's a lot of things that are white light. This flashlight is white light, holds all the colors in the rainbow. And I'm going to use this little refraction disc.
Okay.
It's just like a prism.
So it bends it.
So it bends it, and it starts to spread it out.
Because it
And
doesn't
what we're
bend
go-
all the wavelengths equally, see? So.
I got
Exactly.
you. Thank you, Mr. Z.
Yep.
And right now, as you can see, all the colors in the
I
rainbow
can see
show
them, yeah.
through.
Yeah.
And that's why all the colors of the rainbow are in this light. They're in white light. That's why you see a rainbow. And we're going to talk about that in another couple of seconds. But right now, I want to talk about these three things.
All right.
What are these?
Color disc?
Color disc.
Okay, color disc. I was going to say
Colors.
more.
No, you can jump right in there. Feel free.
Primary colors.
Primary colors.
All
And
right.
primary colors are
Yellow. You always want me to do it.
It's
huh?
all right. Magenta?
Magenta. It's
magenta
cyan.
and
Yeah.
cyan. Or when you're in kindergarten, it's always red, yellow, and blue.
Yeah, Mr. Zuniga knows this much better than I do.
Yeah,
So I'm glad I
you know
can
it
answer
better
what
than
I
I
can.
do. So we've got someone to fall back on.
All right,
And
yes.
turn around now. What can you do with all these primary colors? What's the cool thing you started to learn in kindergarten?
Mix them.
Mix
match
them to make
yeah.
different colors. So let's think of a cool color. What do you think we're going to put yellow and cyan together? What color do you think we'll find?
Blue?
You're
Or
Irish.
Green? Yeah, green. All right, I'll say a green then. Oh, yeah.
Yeah.
Clearly a green, yeah.
Clearly a green. So that's
Okay,
green.
because cyan is the blue. I got
The cyan is the blue. Now, how about magenta and yellow?
All right, I'm going to let you do this one, Mr. Z.
All right, so we're going to get our orange now.
I need an orange.
Yeah.
And there's our orange.
All right.
Pretty cool.
And I
now,
think I know the next
we've
one.
got, do you? All right, magenta and the cyan,
And will be a purple.
purple.
Yeah. That is cool how you did that. Thanks,
Now that
Tim.
shows all the way through.
Yeah.
Those are the primary colors. Now, there's additive and subtractive primary colors. So now these colors, we took them all, we put them together to make other colors. So right now, I'll ask you, which do you think it is, additive or subtractive? Now, I know you guys know.
Yeah,
So let's
yeah.
ask you out there, how many folks think that these are additive primary colors? Show of hands. It's kind of a lot. How about subtractive primary colors?
There we go.
Not so many, but some up here. And actually, the thought is because you put them together, they're going to be additive primary colors, but they're
All right.
actually subtractive primary colors.
That is interesting.
Subtractive
Why is
primary
that?
colors, they have to do with pigment. The color of your hair, the color of your shirt, the color of your carpet, the paint on the walls. That is, it's subtractive because, well, let's go back to the flashlight.
Okay.
We've got the flashlight. We'll point at Mr. Z's shirt.
All right.
We're hitting
Is
Mr.
Graham's
Z's
tie
shirt.
working?
Now, all the colors of the rainbow are hitting Mr. Z's shirt right now. Now, what's happening is that pigment is subtracting or absorbing every color in the rainbow except for one. One it can't absorb, and it throws it back at us. Guess what color that is?
It's the same color as the shirt itself.
Same color as the
Yeah,
shirt, the
right,
blue.
blue.
Yep.
It's your green in your tie, the green in your shirt. That's why it's subtractive. It takes all of those colors, absorbs them, and throws them out. In our set, you'll see the orangish, the red up there. That's how subtractive
That's pretty
primary
neat.
colors work. Now, you wonder about additive primary colors. Well, the cool part about that is everybody is looking at it right now. If you're looking at your monitor or your screen, your television, you turn around, it usually lets you change 3 colors in a color television, at least the standard one. And those 3 colors?
Red, green, blue.
and blue. Those are the 3 additive primary colors. They have to do with light rays, electromagnetic waves. And actually, when we take this and we turn it on, what color do we
there.
see on the screen?
I see no colors. I still see white.
You still see the white.
Yeah.
That when they blend together, they make white light. Now, to see the colors, you just have to look a little bit closer.
Ah, look at that.
It's the shadow. It's the yardstick takes out some of the colors. Another cool way is actually to use your hand. And you can see that all of the colors of the rainbow are in the white light. And it's because your hand or whatever object you have going in front of the light is making a shadow, blocking out some of the blue, some of the green, some of the red. And that's where you come up with your additive primary colors. You can see down below
is
there's the
neat.
purple, and you've got the magenta up top, the orange, the yellow. You can see cyan. It's tough in this lighting sometimes, but if you try it at home, all you have to do is get a little setup like this. You can get it at any big hardware store, the big box stores type things. You put these together.
So if you put
and
an obstruction in there, it can show the colors.
It can
but
show the
otherwise,
colors.
it dispenses the same amount, and it's just white from all
same
the
as, same as always. And that's why your
great.
televisions, when you hear of pixels, each pixel, you'll have millions of pixels in your screen or in your
I got my
monitor.
computer, yeah.
And each one of those has the ability, has those 3 colors in it, and that's what changes. That's what makes computers and some of the monitors so cool.
Right,
And the other
right.
thing, magenta. Magenta's not a real color.
Okay, you'll have to explain that to us.
It's either an extra or a non-spectrum color, depending on your outlook on light.
So we won't see it on the rainbow?
You won't see it on the
Magenta?
rainbow. Well, you might see it in the rainbow, but it doesn't hold a frequency. What happens is, actually, it goes by how your eyes are made up. Your eyes are made up, your retina has 2 things inside your eye. You have rods and cones. The rods collect the light, the cones decide the color. And a lot of times, you turn around and you'll be able to see different colors, but this magenta, this is actually a mixture of blue and red light, because their cones are 3 cones. SML, not small, medium, large, but short, medium, and long wavelengths.
So how your rods and cones read that is how you pick up the magenta.
Exactly.
And those that struggle with colors, they're missing some of that?
They're missing some of that.
Some of the cones.
Exactly.
Yep.
Okay.
And it makes it a little bit harder to see things. A lot of times, like your deer. Deer have really good rods, but they tend to not have as many cones. That's why hunters will wear that international orange that just sits right out. They can't see it. It just blends in with the
You
background.
can't see that, huh? I
Good.
didn't
And so
know
that's
that.
why.
And it's cool because some animals actually see in the range beyond what we can see. You know, bees see in the ultraviolet. To them, a flower, the part that they go to would really be bright. You know, they don't
Exactly.
even see the color. So it's cool when you.
Yeah, pretty cool when you
Yeah.
really.
So what do bees have? That
They
make them see
just
that?
their cones are tuned to a different wavelength.
Oh, it doesn't matter if they have more or less.
No.
It's just that they have that
just
different
a
frequency.
different tune. More or less things like owls. You always think of owls outside in the dark. They have a lot more rods than they do cones. I mean, way more. And so that's how they see in the dark.
see.
And that's
Ask
what's really
questions.
cool about color. Light
Yeah,
and
it is
color,
very cool.
additive primary colors, just really pretty sweet. It's interesting.
Very cool.
Yeah, it is very cool.
right.
Okay,
right.
Tim, I learned quite a bit today. Thanks for
Thanks,
making
Tim.
the trip.
Thanks for coming
thank
in.
you for having me. I
right.
love being here with you guys.
Well, we'll
Always
have
a
you
pleasure.
back again soon. We know.
All right.
right,
Well,
sure.
thanks, Tim. Now, if you'd like to know, learn more about the Rochester Museum and Science Center, head to our website, homercotline.org. But stay tuned, and we'll be right back in just a second.
Right.